In this video, I look at the perspectives of Ohio State students regarding the inclusion of PhET sims in our general chemistry labs. Recently, there's been a call for greater evidence that laboratory courses, laboratory activities are beneficial. They definitely take a lot of resources, but what is the evidence that they help? What are students' perspectives? Here's some quotes that I have from students describing their experiences, ranging from possibly the best learning tool I've used all year, or it just made things more confusing. Notice how these students are talking about conceptual understanding. When I think about PhET sims, I'm viewing them along a continuum. Some laboratory experiments are really about the process of how you can do science. You can also have aspects that are not about that process of doing science, but rather are other ways of thinking about and learning the scientific content. When I think about the PhET sims within our labs, we're prioritizing more how they can support content learning within the class. Now, in order to understand learning in general, I need a model for that. A really powerful one for me is described in this book of Learning as a Generative Activity, where it points out different aspects of learning in terms of selecting information, organizing it, and integrating it. This is a common model that you may have seen before, where there's information that must be selected, organized, and integrated. Information first reaches our sensory memory. It's not kept there very long. A lot of information can come in, and then a subset of that is selected and makes its way into the working memory. Very short duration here, not much can be held within the working memory. The goal then is to take the important ideas and to store it within our long-term memory. It can stay there a long time. Notice how it would get recalled back to the working memory if we want to then do something with the information. This idea of the working memory, that's something that can be overloaded. There's a lot of studies looking at different things that take place in lab where, due to cognitive overload, students have difficulty because they're trying to do too many things. They're asked to do too many things in the moment, and their working memory gets overloaded. That's one thing that simulations are thought to perhaps be able to address. When I look at the labs that we have within our first semester, here's the sequence that we would have. 2 of these are involving PhET sims. When we ask students overall, well, was lab a positive experience? Did it support your learning? You can see we're neutral, trending positive, but we definitely have a range of responses. For several years now, we've also asked students these questions. Which lab best and least supported your learning of course content? And which ones did you like and dislike the most? So we ask that every year, and they've got to put things in each of these particular categories. Within this particular year, here's the data. So for each of these, some students might like the lab, some students might dislike the lab. Some students might think it supports their learning, some students might think it does not. So on balance here, if it's on the top side, those would be examples of they like it or it's supporting their learning the most. If it's on the bottom side, those are students saying they dislike the lab and it provided the least amount of learning. I mean, one thing you notice, there's a pretty even balance around the negative. But in terms of the positive, there's one lab that really jumps out, and this happens every time for the most learning. It's this one using PhET sim to explore molecular geometry, bonding, and polarity. So as authors of lab experiments, I really think we need to get students' perspectives and consider what works. What works for which students? What does not work for other students? I don't think we can make a single change that's going to benefit everyone, but I think with data, we can try to continually improve, maximize the positive effects, and minimize the negative ones. So in this particular study, we're looking at students in the first semester general chemistry. Courses were the same, including the labs, and we ask an open-ended question. Which lab best and least supported your learning of course content? And tell me why. This provided a whole bunch of qualitative data that we could then code, and it led to different categories that emerged. If you recall, we had two different PhET sims, one that was looking at the emission of light and one that was looking at our VSEPR predicted geometry and polarity. I really like this quote for what simulations can allow the user to do. This language that they invite the user to explore ideas. Invite the user to explore. I love that language. We took these PhET sims and we also paired them with tangible things they would be doing in the space. So we had an experiment where they could look at the emission spectra for hydrogen, for helium, and connect that to the simulation. And similarly, when they were doing VSEPR predicted geometries, we had physical models paired with that. Here's an excerpt that we have for the PhET sim that was looking at the wave nature of light. This is how it started. We're using language that you see in a lot of descriptions of PhET activities. Start by playing with it. See if you can figure out different things. In terms of the VSEPR one, we had quite a few opportunities where the student would make a prediction and then seek to test it within the simulation. Taking back then the responses and thinking about this model, we were able to encode the responses of students if they were describing a particular laboratory activity as supporting learning or not supporting their learning, and put it into these different categories. Many times they would express a general sentiment. They would say that the lab supported their learning using language like, it was clear and straightforward. I knew what I was supposed to be doing. I knew what the purpose was. Or negative sentiment, it was just unclear what I was supposed to be doing. It was confusing in the space. There was timing, beneficial paired with the class and prior to an exam. Less helpful if it was a large mismatch between what they were doing and when the exam was going to be. The topic, was it a topic that they thought was useful to explore within the lab? Was it related to the class? Was it necessary, meaning they still had some difficulty with it? Was it unrelated or not necessary? Not necessary might mean they already understood the idea. And then a lot of really good language here describing the process. Positives, they would describe it as a visual experience, fun and engaging, hands-on. They could practice things. There were real-world applications. Negative comments, sometimes by other students on those same experiments. The process was too elaborate. It was boring and tedious to collect the data. It wasn't hands-on in some ways. They had to do things again and again. Or a scenario was provided and it was confusing. Notice how a lot of these match up. One student might say, I enjoyed it being a real-world application. And another student might look at the same lab and say, no, that was just a confusing scenario. If we look at some of these and connect it back to this model here, the topic of the lab is important. Was it viewed as being related to class and necessary and in some way supporting their learning? That's all about the performance. They're considering their lab experience and they're thinking about the performance, not just in lab, but how it would appear on the test. When I think about this for the PhET sims and the labs in general, the molecular geometry sim, a huge strength of that is it's closely tied to the performance of what they're going to have to do in lab. The hydrogen atom sim activity, it's less clearly tied. It's got a lot of ideas, perhaps too many ideas, and it's not as directly tied to what they're going to have to do on the subsequent test. We also found it's very difficult to have our initial labs really address learning objectives that the students find important. They don't really see those tasks as related to things that they would have to do on a subsequent test. The timing of the lab, I think it's related to all of these factors. All of these factors because it's related to their prior knowledge and what does it mean for them to be able to select a subset of information, have prior knowledge that they can now use to organize it and integrate it with their long-term memory. Learning within the course and the timing of it, I think, is closely aligned with these different things that one has to do in order to learn and remember the information. Now, you might say, well, the students should be able to do this anytime. They should be able to select the important ideas and organize it if I provide them with pre-lab resources. Really? Think about what you're asking within that. I used to have this perspective saying, well, we gave them the information, but now I've come to understand, certainly from the student's perspective, it can be too much. It can be too much, and it really does not give them any prior knowledge to allow them to have a better laboratory experience. Now, an advantage of the sim is it provides a little bit more flexibility in terms of this, because when they're in the lab space, it's a lower stakes environment. They're not going to break something the same way. Now, we've also found, though, for some students, it could be considered too low of stakes. Why did I have to come to lab to do this? This could have just been a homework assignment. This idea of instruction in the lab space, a lot's going on within one's sensory memory, and a subset of that is selected. It's definitely tied to the procedure and what they're doing in the laboratory space. Students that described a lab experiment as supporting their learning oftentimes use language of saying there was a direct and visual response. They could immediately see the phenomena. If they were not learning, they would describe the process as being quite elaborate, confusing, and any understanding they were supposed to have was not in the moment. It was delayed. So a really important question, I would say, is when one is in the lab, is there an opportunity for this generative learning to take place within the laboratory period? Are they busy doing things, or are they doing things and also thinking about them and beginning to organize that information? This idea of the procedure and what they're doing, we saw that for many of the experimental labs, the traditional wet chemistry labs, this visual component stood out. So here's this for different labs. You see many times the students describing things that they see. They thought the lab was helpful because they could observe the phenomena. They could see things reacting. It was a very visual experiment. It gave them a physical view of something. They're describing in the physical space macroscopic observations that they think are valuable and can take place within the laboratory period. When we look at that language of students saying they could see something, it was visual. When they use that language, the experiments that provided an immediate observation, that language showed up quite a bit. They mix two things together, the color changes. They combine things, they see it precipitate. It's right in the moment, and they describe that as being beneficial for their learning. These two, where it shows up even more, these are the two simulations. Students describe this visual component very frequently within those, but they mean something different by that. They're saying, this helped me picture something. I could visualize a conceptual feature. It helped me create a mental image. What they're describing here is a connection between a symbolic and this particle level representation. The PhET sim, that is a strength that it has. When we're looking at these two particular simulations, it's really helping them develop a mental model, a conceptual model for what is going on. So in conclusion, as I think about this model for learning, whether we're in lab or outside of lab, and how it pertains to these sims, I really am asking myself more and more, well, what will the students actually see in the lab, and how will they make sense of information in that moment? I have questions about learning now before the lab. What information should students know prior to coming to lab, and how should we present that to them? When they're in the laboratory space, is there an opportunity now to process information and make decisions? As they're doing that, how should they document what they're doing in the lab? Is there an opportunity for them to check their understanding within the laboratory session and try something different? A lot of times in a chemistry lab, we have an extended procedure, and they can't really do that. And then afterwards, how are they going to get feedback on whether they were successful or not? Are they ready to receive that feedback? And what are they supposed to do with it? Is it just a score, or is it something that they're going to act on? These are questions that I think are important for all labs, but I really learned a lot about all of these as well by looking closely at how students perceive our PhET simulations and what happens when we put those into a laboratory environment.